Tajikistan is one of the poorest countries in Central Asia, landlocked, with limited fossil fuel resources, a population of just over 10 million people. Yet in a remote valley along the Vaksh River, this small nation is pursuing an ambition far beyond its own scale, building the tallest dam in human history. With an estimated total cost of around $8 billion, the Rogun Dam is designed to stand 335 meters tall, surpassing every existing dam and any skyscraper currently standing in the world. The project is planned to generate 3,600 megawatts of electricity, equivalent to the combined capacity of multiple nuclear power units. But to understand why a country like Tajikistan is willing to stake nearly its entire future on a single dam, join Mandrin Tech as we turn back time, far back into the past. The idea of the Rogun Dam is not a product of the 21st century. It first emerged in the 1960s, when Tajikistan was still a republic of the Soviet Union. In the context of the Cold War, Moscow was pursuing an ambitious strategy, industrializing its peripheral regions, especially Central Asia, through massive infrastructure projects. The Vaksh River, a major tributary of the Amu Darya system, quickly came into focus. With its powerful flow, high mountain terrain, and dramatic elevation drop, this was one of the few locations in the world capable of supporting the construction of ultra-high dams. In 1976, the Soviet Union officially launched the Rogun project. The objective was clear: to build a dam that would surpass all previous hydropower projects, one capable of controlling the river, generating electricity on a massive scale, and regulating water for the entire region. But history did not follow the plan. After the collapse of the Soviet Union in 1991, Tajikistan descended into civil war. Its economy collapsed, and Rogun, still only a partially built construction site, was abandoned. It would take more than 2 decades for Rogun to have a chance at revival. According to engineers, when completed, the Rogun Dam will stand 1,099 feet tall, equivalent to approximately 340 meters. This will make it the tallest dam ever built. The Rogun hydropower plant is designed with 6 turbine units, with a total installed capacity of 3,600 megawatts. This amount is sufficient to double Tajikistan's current electricity output, creating a significant surplus of power during the summer months. Rogun is not a conventional concrete dam. It is a rock-filled dam with a central clay core. The dam body is formed from hundreds of millions of tons of rock and gravel, compacted layer by layer. The clay core serves as an impermeable barrier, while the massive rock-filled shoulders provide structural stability and energy absorption. The reservoir behind the dam has a capacity of approximately 13 cubic kilometers of water, making Rogun one of the largest reservoirs in the region. This volume allows for seasonal flow, regulation, more stable power generation, and support for irrigation in downstream areas. Everything begins with diverting the river, because in order to build the dam, the foundation area must be kept dry. For Rogun, this meant drilling massive diversion tunnels through the mountainside. 4 tunnels were designed, each more than 1 kilometer long, with diameters reaching tens of meters. 2 of these tunnels were constructed during the Soviet era and were later rehabilitated and reinforced. The remaining 2 were completed during the project's restart phase. These tunnels allow the Vaksh River to bypass the construction site, clearing the way for the main construction phase. Before the dam body could begin to take shape, the foundation of Rogun had to be treated thoroughly. Weathered soil, rock, and weak materials at the valley floor were excavated to expose stable bedrock. Natural fractures within the rock mass were drilled and injected with high-pressure grout to reduce seepage, strengthen cohesion, and control groundwater flow. At the same time, a foundation drainage system was installed to reduce uplift pressure beneath the dam throughout the structure's entire service life. In parallel with foundation treatment, the rock slopes are reinforced through rock bolting, steel mesh installation, shotcrete spraying, and drainage to ensure long-term stability before dam embankment begins. Once the foundation and slopes meet safety requirements, The Rogun Dam body is constructed in stages under a strictly controlled process. Rock and gravel are extracted on site or transported from nearby areas, then placed in thin layers, leveled, and compacted to ensure long-term stability and minimize uneven settlement. At the center of the dam body, the clay core is built simultaneously and carefully protected to maintain impermeability. Throughout this process, engineers continuously monitor settlement, water pressure, and dam deformation, while inspecting and test operating the discharge and control systems to ensure all parameters remain within safe limits. At the same time as foundation works are completed, the spillway structures and vertical shafts are constructed deep within the rock mass through vertical excavation, reinforcement installation, and staged concrete placement, forming safe water conveyance paths and controlling hydraulic pressure throughout both the construction and operational phases of the dam. After the vertical shafts and tunnels are fully excavated, the tunnel structures are constructed by installing reinforcement, formwork, and placing tunnel lining concrete in segmented sections, forming a load-bearing and waterproof lining for the tunnel system and discharge routes. Next, the tunnel invert and the floor of the discharge structures are completed to provide a stable load-bearing foundation for the entire system. Reinforcement and drainage layers are installed before the floor. Concrete is poured in segmented sections, ensuring strict control over thickness, strength, and surface quality. The first two turbine units began generating electricity in 2018 and 2019, marking the transition from a purely construction site to an operating power plant. The electricity produced during this phase both supplies domestic demand and allows engineers to verify the design and operating systems under real conditions. According to the current plan, the dam body is expected to reach its design height around the year 2029. However, reservoir impoundment will be carried out cautiously and over a longer period. It is projected that the Rogun Reservoir will reach its maximum water level around the year 2036, fully completing the dam's role in regulation and power generation. For Tajikistan, the Rogun Dam is not merely an engineering project, but a national-scale financial gamble. The total construction cost is estimated at around $6.3 billion, an amount equivalent to nearly half of the country's GDP. For a small economy with limited revenue and heavy reliance on remittances, this represents an unprecedented financial strain. For many years, Rogun suffered from severe funding shortages. International donors remain cautious, not only because of the dam's immense scale and technical complexity, but also due to the political risks surrounding the project. The core of these concerns lay with downstream countries, particularly Uzbekistan, whose agricultural sector depends heavily on water from the Amu Darya river system. The prospect of Tajikistan controlling a massive upstream reservoir raised long-term water security fears across the region. In this context, the World Bank agreed to become involved only after demanding a series of independent feasibility studies and comprehensive regional impact assessments. Rogun Dam is not just a hydropower project. It is a stress test for everything Tajikistan has placed its bets on: engineering, finance, politics, and its future in a world of rapidly accelerating climate change. If successful, Rogun could transform a poor nation into an energy hub of Central Asia. If it fails, it will stand as one of the most expensive gambles in modern infrastructure history. But the final question is not simply how tall Rogun is or how powerful it can be. The real question is whether a single dam can carry the future of an entire nation on its shoulders. When upstream glaciers are retreating, downstream pressures over irrigation and economic interests are mounting. And in between lies the challenge of capital, timelines, and trust.